Hello guys, welcome back to the quantity solving workshop and to another video. In today's video we are going to be learning how to build up rates for machineries, and for today's case study we are going to be using a concrete mixer. So there are times in construction where the construction firm would prefer to use to anchor their project with machineries instead of manual labor. So if you are using a machinery, for example, it means that when you are building your rates, you have to build your rates for the machine itself, the labor, that's the operator of the machine, and then for the cost of fuel. So those are the three major things you are going to be booking for, or you are going to be using to build up the rates for your plant. So when building up our rates, the things you have to put in mind for every plant or every machinery are as follows. Number one, the price. As you can see, the price is stated here, the type of the machinery, the capacity of the machine, and then the hourly productivity of the machine. These values, or this piece of information, is going to be used to build up rates for any machine. And in this case study we are using a concrete mixer. So the first thing now we're going to be doing now is to build up the daily rates for this machine, for this concrete mixer. And how do we do that? The first thing we have to do now is to know how much we bought the concrete mixer. And as you can see this example, it is stated that the concrete mixer was bought for 3.5 million naira. So since the capital cost, that's the cost incurred to purchase this concrete mixer, is 3.5 million, now you know that machinery is a fixed asset, and fixed assets are liable toward depreciation. You now have to allow for a certain percent for depreciation depending on how long you want to use this particular concrete mixer. So for example, if I was the firm and I bought this concrete mixer at 3.5 million naira, I will now ask myself, okay, how long do I want to use this particular concrete mixer before I replace it? So for example, now I will say for 5 years. So it means that after 5 years I ought to have replaced this concrete mixer with a new one, because as time goes on, the efficiency of this concrete mixer begins to reduce. So it means that from now that I bought the concrete mixer, to the next 5 years, for every project I'm going to be using this concrete mixer for, I have to be allowing a certain percentage that will be saved, so that in the next 5 years I would have already saved up enough money to change the concrete mixer into a new one. So we have to be allowing a certain percentage on the price of this concrete mixer. We also have to allow for the cost for repairs and maintenance, a certain percentage for repair and maintenance. We now have to also allow for a certain percent for the capital cost. So you know that this price, 3.5 million, that we've used to buy this concrete mixer is an investment to the business. So this concrete mixer is supposed to be working for us, meaning that it's supposed to be bringing a certain amount of revenue towards the business or to the firm. That is what this cost of capital is. So we have to also allow a certain amount for this cost of capital. Now, with all this I've said, you can now use it to determine the daily rates for this plant. The daily rates for the plant, which is the concrete mixer. So now let's start so that you can understand it better. So the first thing now is what? The capital cost. How much you use to buy the machinery. So capital cost is equal to what? 3.5 million naira. So now, like I said, we are going to be using this particular machine for what? 5 years. So replacement after what? 5 years. So it means that as we bought this machinery new, it is working 100% efficient. So it means that in the next 5 years, we need to know how much depreciation this machinery would go through per year, since we are going to be using the machine for 5 years. So since as we bought the machine, it is reading 100% efficient. So it means that every year, there's going to be what? 20% depreciation, because 100% divided by what? 5 years is going to become what? 20%. So it means that we need to be saving at least 20% of our capital cost every year. I hope you understand what I just said. So it means that every year we ought to have saved about 20% of the capital cost, so that in the next 5 years we would have gotten equal to or more than this was 3.5 million that we used towards buying the concrete mixer. So now we can now say yearly replacement. So it means that every year we ought to what? Save 20%. So you now have to check what is 20% of 3.5 million. 20% of 3.5 million is equal to 700,000 naira. So the next thing you are going to be adding is your what? Cost of capital, which is the revenue to be generated because we use this money that we use to buy the machinery is what? An investment. So the cost of capital, 25%. So 25% of 3.5 million naira is what? 875,000. And then the last thing will be what? Repair and what? Maintenance. So this would be, we're allowing for repairs and maintenance because, you know, as time goes on, this machine can get faulty. So we have to be allowing a certain amount for what? The repair and what? The maintenance. So we're going to be allowing 20%, which is 700,000. So if you find the summation of all this, 700,000 plus 700,000 plus 875,000, and that will give me what? 2,275,000 naira. So this is what we ought to have saved in a year, 2,275,000. But we are looking for what? The costs for this plant per day. So what can we say now? We can now assume that in a year we are going to be using this concrete mixer for what? 160 days. So we can now say consider usage per year is equal to what? 160 days. So since in a year we are going to be using this equipment, this machine for 160 days, we can now say what would be the cost per day. So since we know how much we ought to save in a year, and this is how many days we ought to use this machinery in a year. So we can now divide 160 days by what? This. So cost per day will now become what? 2,275,000 divided by what? 160 days, and that would be equals to 14,218.75 naira per day. I hope you get the logic. So now the first thing we have done is for the what? Plants. The next thing we're going to now be doing is for what? The operation. That's the labor operating these machineries. So we've done the section for plant. The next section now is what? Operating labor. So now we can now assume that we are going to be having one operator for this machine and one assistant. So the main operator would be on the wages of the skilled labor, while the assistant would be on the wages of what? Unskilled. So meaning that we have one operator and what? One assistant. So for the operator, you are going to be giving the operator the rate that you've built up for skilled laborer, because you need to be skilled to know how to operate the concrete mixer. So you know that in the building up of rates for skilled labor, we calculated it as 613.93. Then for the assistant, you give the assistant for what? Unskilled. Which we deduce as 219 naira 94 kobo. So after doing that, we will now have to add these two together, and we have 833 naira 87 kobo. So this is what these two people, the operator and the assistant, will be earning per hour. So in a day, they will be working for what? 8 hours as the standard. So we have to determine how much it will now be per day, which is per 8 working hours. So we'll now say hence cost per day will now be equals to what? 833.87 multiplied by what? 8 working hours, and that will be equals to 6,670.96 naira per day. So this is what the operator and the assistant will be earning what? Per day. So as you can see now, if you look at that of the plant and that of the operating labor, you are seeing that we are deducing everything by a common unit, which is the cost per day. For the plant, we have what? 14,218.75 naira per day, and for the operating labor, we have 6,670.96 naira per day. It is important that these two units be uniform. You should already know that in your physics. So whatever you are calculating, the units should be uniform. That is why the two of them is in cost per day. So after we've done for the plant, we've done for the operating labor, then we need to now deduce what the cost of fueling this this machine will be per day. So in order to do that, you have to determine how much fuel, how much liter of diesel this concrete mixer consumes in a day. So if you can deduce how many liters of diesel this mixer consumes in a day, then you can now determine what the cost would be. So the next thing we're going to be doing now is for the fuel. So we're going to be assuming that this concrete mixer consumes about 20 liters per day. So since we know that this concrete mixer consumes 20 liters per day as per diesel, we now need to know how much is the current price of diesel now. So we know that the current price of diesel now, 1 liter of diesel is 1,000, let's just say 1,600. So we're now saying if 1 liter is at 1,600 naira, therefore cost of 20 liters will now be equals to what? 20 times 1,600, and that will be equals to what? 32,000 naira per day. So doing this, you've determined the cost for the diesel that this concrete mixer is going to be using per day, which is what? 32,000 naira. So going after you've gotten the cost per day for the plants, the operating labor and the fuel, you now have to add what you've gotten together. So we can now say summary. For the plants, for the labor, and then for the fuel. So what did we get as our cost per day for the plants? 14,218.75. Then for the labor, we had 6,670.96, and then for the fuel we had what? 32,000 naira. When you add everything together, it's going to give you what? 52,889.71, meaning that this is your total cost for the plants, the labor and the fuel for that concrete mixer per day. So now we have to break this unit per day into the cost per meter cube. And how do we do that? We can now relate this cost per day for the concrete mixer to the cost per the volume of that concrete mixer. Let me see if I can explain this better. So we know that the concrete mixer per day, the cost for the concrete mixer now that we've allowed for per day is 52,889.71. So we want to relate it to meter cube, meaning that since the cost per day for the concrete mixer is 52,889.71, we have to relate it to the volume of concrete that concrete mixer can mix in a day, so that we can use that information to then determine what will be the cost per meter cube of the concrete mixer. So we know that the capacity of that concrete mixer in cubic meter is 0.31 meter cube as stated. So we now need to know how many cubic meter this concrete mixer can mix per day. So in order to know how many cubic meters this concrete mixer can mix per day, we need to determine what is the productivity of this concrete mixer per hour. I hope you are getting the logic. So when we can determine the productivity of this concrete mixer per hour, we can now multiply it by our 8 working hours to know how many meter cube this concrete mixer can mix per day. So to do that, we can now say, consider hourly productivity equals to 4.65 meter cube per hour. This means that the concrete mixer can mix about 4.65 meter cube in 1 hour. So that is the productivity of this concrete mixer per hour. So since we know the productivity per hour, we can now deduce the productivity per day. The quantity of concrete this concrete mixer now can mix per day. So we can now say capacity per day will now be equals to the productivity per hour, 4.65 multiplied by 8 working hours. That will now give us 37.2 meter cube per day. So it means that this concrete mixer can mix about 37.2 meter cube in a day. So since we know that this is what the concrete mixer can mix in a day, we can now relate it to the costs that we've calculated for the concrete mixer. So we can now say that the costs for this concrete mixer, which is 52,889.71, can also be said as the cost for this concrete mixer to mix 37.2 meter cube per day. I hope you get the logic. So I just related the cost of this concrete mixer per day to the cost of how much that concrete mixer can mix per day. I want to hope that you understand the logic, the premise I just made. So moving further, you can now say therefore 37.2 meter cube costs 52,889.7 naira. So since this is the volume of concrete this concrete mixer can mix in a day, and this is the cost for this volume of concrete the concrete mixer will mix in a day, we can now use this information to derive the cost of this concrete mixer to mix 1 meter cube of concrete. So we can now say, since we know this, therefore 1 meter cube costs, you can now say 52,889.71 divided by 37.2, and that will give us 1,421.77 naira per meter cube. So we now have to add our profit and overhead. So let's just say in this case we add 30% profit and overhead. So 30% of this particular price, that's of 1,421.77, is going to give me 426.53 naira. So when we add the two together, it's going to give me 1,848.30 per meter cube. So it means that this is this is the rate, assuming you are the owner of assuming you are the owner of the concrete mixer, this is the rate per meter cube that you will be giving anybody who wants to use this concrete mixer, or it is the rate you'll be adding to your build-up for every operation that consists of using this particular concrete mixer. So I hope everything we've discussed was easy to understand, was well understandable. So we've come to the end of today's video, guys. I hope you derived adequate knowledge from it. Please do not forget to like, share and subscribe to this channel if the channel helped in one way or the other. Thank you, and we'll see you in the next video.